In this video, I am going to discuss about rolling process, hot rolling and cold rolling process, types of rolling. Rolling. Rolling is a metal forming process in which the material is allowed to pass through between rotating rollers in order to reduce the thickness and to obtain desired cross section. So that's the definition of the rolling process. Basically, a rolling process is a metal forming process. Metal forming process means changing the shape of the metal. So in a rolling process, the material is allowed to pass through between rotating rollers. So there are rotating rollers and the material is passed through the rotating rollers in order to reduce the thickness and obtain desired cross section. See, during rolling process, metal is plastically deforming by passing between rollers. So during a rolling process, the material undergoing plastic deformation by passing the material between two rotating rollers. See, during rolling process, the work is subjected to high compressive stress due to the squeezing action of the roller and surface shear stress as a result of friction between roller and the metal. So during rolling process, compressive stress will be acting over the material due to the squeezing action of rotating rollers, and also there will be surface shear stress will be there as a result of friction between roller and the metal. See, this is the diagram of a rolling process. So in a rolling process, the material is allowed to pass between rotating rollers. So these are the rotating rollers. Rotating rollers are rotating in opposite direction. So due to the squeezing action of the rotating roller, there is a high compressive force will be acting over the material. And there will be a surface shear stress will be producing. See, this is the surface that is undergoing rolling process. So here a surface shear stress will be producing due to the friction between roller surface and workpiece surface. So during rolling process, the material that is allowed to pass through between rotating rollers in order to reduce the thickness and obtain desired shape. So during a rolling process, the material is deforming plastically by passing between two rotating rollers. Rolling processes are classified into two types: hot rolling process and second one is cold rolling process, depending upon the temperature at which the rolling process will be happening. See, first of all, hot rolling process. See, in a hot rolling process, the metal undergoing rolling process is initially heated above recrystallization temperature. Above recrystallization temperature, below melting point, and the rolling will be taking place. So in a hot rolling process, the metal that is undergoing rolling process initially heated above recrystallization temperature. So what do you mean by recrystallization temperature? Recrystallization temperature is the temperature at which new grains start to develop or form over the parental grain structure. That temperature is known as recrystallization temperature. So in hot rolling process, the metal initially heated above recrystallization temperature and the rolling process will take place. See, in a hot rolling process, this is the diagram of grain structure in a hot rolling process. In a hot rolling process, after stress zone, so this is the stress zone or rolling zone. After the stress zone, the grains start to elongate in the direction of rolling. So you can see that the grains start to elongate in the direction of rolling process, and after the grains start refined, a new grain structure will be formed. So this is a refined grain structure. This is the original grain structure and this is the elongated grain structure. So hot working process always improve the strength of the rolled product. So hot rolling process, the metal is initially heated above recrystallization temperature and rolling will be taking place. So hot rolling, after the stress zone or roll zone, the material start to elongate and after that it will refined grain structure will be produced. Hot rolling always increases the ductility of the rolled product. See, in a cold rolling process, the material is heated below recrystallization temperature or otherwise the rolling will be taken place at room temperature. See, in a cold rolling process, the grains will tend to retain the shape after the rolling process. The grains start to retain the original shape after the rolling process. So after stress on, the grains elongate but it will retain the shape after the rolling process. See, cold rolling process that will increase the work hardening and strain hardening of the metal. That's the important process point. Cold rolling always increase work hardening or strain hardening. So this is the diagram of a cold rolling process. So difference between hot rolling and cold rolling. This is very important. Difference between hot rolling and cold rolling process. So we have hot rolling and cold rolling. So first point, metal is fed into rollers after being heated above recrystallization temperature. So in hot rolling process, metal is fed into rollers after being heated above recrystallization temperature. In cold rolling, metal is fed into the roller when its temperature is below recrystallization temperature or room temperature. Second point, coefficient of friction between rollers and metal is higher in hot rolling, but in cold rolling, coefficient of friction between roller and metal are lower. See, third point, in hot rolling process, heavy reduction in cross-section area are possible in hot rolling as there is high coefficient of friction between the roller and metal. In cold rolling, heavy reduction in cross-section is not possible. Fourth point, in hot rolling, closed dimensional tolerance cannot be obtained. In cold rolling, closed dimensions can be obtained. Actually, hot rolling is a rough work. Closed dimensions tolerance cannot be achieved. It is used to reduce thickness in large dimension. But cold rolling, that is considered as a finishing process in order to achieve the closed tolerance. Hot rolling always result poor surface finish. Cold rolling that result smooth surface. Even oxide free surface can be produced. Sixth point, hot rolled metals do not show work hardening effect, but cold rolled metals always show work hardening effect. So work hardening effect is completely not present in hot rolled product, but cold rolled product work hardening effect will be there. See, in hot rolling, ductility increases, strength and hardness decreases. In cold rolling, strength and hardness increases, surface finish increases, reduce ductility. That's a very important point. In hot rolling process, ductility will be increased. That's why elongation will be there. There will be large amount of reduction will be there. But strength and hardness decrease. In cold rolling, strength and hardness increase, but ductility will be reduced. See, in hot rolling, massive deformation will be possible. But in cold rolling, massive deformation is not possible, but excellent surface finish will be obtained after cold rolling process. So these are the difference between the hot rolling and cold rolling process. This is an important question. You have to write like this. If in university examination, suppose a question like compare hot rolling and cold rolling, etc. you have tried like this hot rolling process and cold rolling process. Okay. Next one, types of rolling mill. There are 6 different types of rolling mills are used in the industry. 2 high rolling mill, 3 high rolling mill, 4 high rolling mill, cluster rolling mill, planetary rolling mill, and sixth one is tandem or continuous rolling mill. So these are the 6 classification of rolling mill that is used in the industry. Once more, 2 high rolling mill, 3 high rolling mill, 4 high rolling mill, cluster rolling mill, planetary rolling mill, tandem or continuous rolling mill. So we can discuss one by one. So first one, 2 high rolling mill. So this is the figure of 2 high rolling mill. 2 high rolling mill, that's a basic type of rolling mill. 2 high rolling mill contain 2 heavy rollers fixed one over the other. 2 high rolling mill which contain 2 rollers which is fixed one over other. And these 2 rollers are rotating in opposite direction by electric motors. The direction of motion of the rollers cannot be changed. So always work has to be fed into the roller from one direction only. So operator cannot change the direction of rotation. So workpiece will be always feeding in one direction. If more than one pass is required, the material will have to be brought back to the same after the first pass. So this is known as 2 high rolling mill. So 2 high rolling mill consists 2 rotating rollers one over the other. So these are the 2 rotating rollers. These rotating in opposite direction. In the case of 2 high rolling mill, the workpiece will be always fed in one direction only. So after completing the one pass, if we want to any one more pass, the workpiece will be brought back to the same side. Okay. Second one is 3 high rolling mill. See, the second type of rolling mill is the 3 high rolling mill. See, this is the figure of 3 high rolling mill. See, 3 high rolling mill consists 3 rollers positioned directly over one another. See, 3 high rolling mill that consists 3 rollers. So this is the first roller, this is second roller, and this is third roller positioned one over others. The direction of rotation of first and second rollers are opposite. See, the direction of rotation of first roller and second roller are opposite, and direction of rotation of second and third rollers are opposite. Okay. See, the what is the main advantage of 3 high rolling mill is work material can be fed in one direction between the first and the second roll, and the return pass can be provided between the second and third roll. So you can see that first pass we have first roller and second roller. The workpiece can be fed between the first roller and second roller. If you require the return pass or again one more pass, the workpiece can be fed between second roller and third roller. So there is not need to workpiece can be taken again to the opposite side as in the previous one. So this is one of the advantages of a 3 high rolling mill. Okay. So 3 high rolling mill consists 3 rollers fixed one above each other. First and second will be rotating in opposite direction. Second and third will be rotating in opposite direction. So 3 high rolling mill are commonly used if one more pass is required to reduce the thickness of the workpiece. Third one is 4 high rolling mill. See, this is the figure of 4 high rolling mill. 4 high rolling mill consists 4 horizontal rollers, 2 smaller diameter and 2 large diameter. See, 4 high rolling mill consists 4 rollers. These are fixed horizontally, one above other, and 2 large rollers, that is known as backup rollers, and small rollers, that is known as working rollers. Actually, small rollers are doing the rolling operation. Backup rollers hold the working rollers and restrict deflection when material being rolled. So in a 4 high rolling mill consists of 4 rollers, that is fixed one above other in a horizontal direction. So large 2 rollers are known as backup rollers and small 2 rollers are known as working rollers. Actually, these working rollers will be contact with the workpiece. And what's the purpose of the backup rollers is which prevent restrict deflection of the working rollers when material being rolled. Okay. So fourth one is cluster roller. See, this is the figure of cluster roller. It consists of 2 small diameter working rollers and 4 or more backupping rollers. So in a cluster rolling, which consists 2 working rollers. So these are the 2 working rollers. One will be here and 2 will be here. Second will be here. And these 4 rollers are backupping rollers. They have a large diameter which will restrict or prevent the deflection of the working roller during rolling process. So that configuration is known as cluster roller mill. And fifth one is the planetary rolling mill. See, this is the figure of planetary rolling mill. In planetary rolling mill, a large backup roller is surrounded by some planetary working rollers. Each planetary roller gives a continuous reduction during rolling process. So this configuration consists 2 large backup rollers which is surrounded by small working rollers, and each roller that will give a continuous reduction in size during rolling process. See, what's the main application of planetary rolling mill is? It is used to reduce large thickness in a single pass. That's the main application of planetary rolling mill, which is used to reduce large thickness in a single pass of steel strip. See, the planetary rolling mill capacity is higher than cluster rolling mill but less than tandem rolling machine. Its capacity is always higher than cluster rolling mill but it is lower than tandem rolling mill. I am going to discuss next one. Okay. So that's about planetary rolling mill. And last one is tandem or continuous rolling mill. See, in the case of tandem or continuous rolling mill, which is used only in the case of mass production, which consists non-reversing 2 high rolling mills providing one after other. See, which consists several rolling mills that will be placed one after other, and it will continuously reduce the thickness of the workpiece during rolling process. So here one rolling will be taking place, the thickness will be reducing. Again when it reach here, again thickness will be reducing, and third section again reaching, the thickness will be reducing. So it consists backup rollers and for supporting the working rollers. So this configuration is commonly used in the case of mass production only. So these are the classification of different rolling mill that is used in the industry. So there are 6 type of rolling mills: 2 high rolling mill, 3 high rolling mill, 4 high rolling mill, cluster rolling mill, planetary rolling mill, tandem or continuous rolling mill. So in this class I have discussed about the rolling process, hot rolling and cold rolling process. What are the various classification of rolling mill which is used in the industry? Thank you.